Alright guys, we're going to do capacitors. Now, just as a reminder from last time, capacitors are simply two metal plates that have a space between them, D, that store charge on them. One side becomes positive, the other side becomes negative. And based upon basically the area of the plates, the distance between the plates, and a constant, we're able to figure out what the capacitance is, how much charges are going to be able to store. Now there are two equations you need to know, which we went over on Friday. First one is that the real value of a capacitor is based upon that permittivity of free space, matching area, divided by the distance between the two plates. Now, if you know the capacitance, you can figure out how much charge is going to be across that capacitor for any set voltage. So far, so good. Okay, so the zero permittivity free space is 8.85 times 10 to the negative 12 Newton meters squared per coulomb squared. It's actually just the reverse units that you'd have for K, the electrostatic constant. Now let's take a real simple example. Let's say that we've got two plates Let's say we've calculated out that capacitance for these two plates. Let's say that they are a 2 farad capacitor. Capacitance is measured in farads. And we hook these two plates up to a battery that's got a switch in it. Okay, so we close the switch, and that allows charge to build up on the plates. This side's positive, this side's negative, this plate will become negative, this side of the plate is going to become positive, okay? If this is, for example, 100 volts, and we want to find out the charge that's on there, it's pretty simple. C equals Q over V. You've got your capacitance. You've got a 2 farad capacitor. You want to find your charge. And the voltage is going to be 100 volts. That's your electric potential, of course, there. And, of course, Q is going to turn out to be 200 coulombs. That is a huge amount of charge. They really, I don't know if they actually make capacitors that can handle that much charge in them, but we'll use it as an example. Now, let's say we disconnect the battery. We open the switch. And cut the distance between the plates in half. What we want to find out is how is this going to affect our electric potential, the voltage across the plates, and how is this going to affect the charge across the plates? Well, if we close this switch, we allow charge to flow. The moment we open that switch, there's no way for those electrons on this side of the plate to get around and go on to the other side. So by opening the switch, we know that Q must remain the same. It's got to be 200 coulombs. There's no way the charge is going to get around from one side to the other. However, what's going to happen to our voltage? Well, first of all, if we cut the plates in half, we know our capacitance is equal to E0A over D. Let's see what's going to happen. Let's throw some simple numbers in there and see what happens to the capacitance. If I throw in all ones, leave the constant as 1, as E0, I just get epsilon 0. All right, now, let's say that we're going to take this and we're going to cut that distance in half. We're not changing the area, but we are going to take that distance and make it 1/2. That means I'm going to get, which means basically we're going to have twice whatever the original capacitance was. My new capacitance, which was 2 farads times 2, is now we have a 4 farad capacitor. Now remember, the charge stayed on there was the same. C equals Q over V. We know that our charge, of course, was 200 coulombs, was not allowed to discharge. My voltage is going to be changing this time, and my capacitance is now going to be 4 farads. So that means at this point, I'm going to wind up with a voltage of 50 volts. That's pretty straightforward. Now let's close the switch. All right. If we close the switch, referring back to our original diagram here, close that switch. Now charge does have a path from one side over to the other. Okay? So, my Q can change. But now that I'm connected back to the battery, the potential across there is going to go up to whatever the potential of the battery is, 100 volts. It's now to come back up to that same potential as the battery. If you think about voltage as electrical pressure, it's going to build up until it's pushing back with the same type of electrical pressure as the battery was pushing forward. So now let's take a look at this. We know our capacitance, since we changed the capacitor, was 4 volts. C equals Q over V. 4 farads. My bad. All right, so I'm going to have a 4 farad capacitor. I want to find out what my new charge is, and I back up to 100 volts. So now my charge is going to turn out to be 400 coulombs. Really a crazy amount of charge, but it does make things make some sense. Okay? We'll hold off there.